In this question, Beth has 3,000 feet of fencing, and she wants to go ahead and enclose a rectangular field. So part A to this question is asking us to express the area of the rectangle as a function of x, and x is going to represent the length of the rectangle. So let's go ahead and draw ourselves a picture, and we can start labeling portions of our diagram. So I've got my rectangle, and I'm going to let the length be represented by the letter x, and the width of our rectangle I'm going to let be represented by the letter y. So keep in mind what it means to express the area of a rectangle. Go back to your basic area formula for the rectangle, right? We have base times height. You could write it as base times height, or you could go ahead and write it as length times width, whichever one you prefer. So I'm going to talk about it in terms of area equals length times width. And let's go ahead and substitute our variables in here. That means our formula for this area of the rectangle is going to be x times y. Now if we go back and take a look at part A, they're asking us to express this as a function of x, right? That means we should only see x values in our area formula, and that means we have a small problem because we need to replace the letter y. So now we're going to go ahead and try and work with a secondary equation that we can use off of our rectangle. You do have access to a perimeter formula. And keep in mind what it means to calculate the perimeter. Since we're working with a rectangle, we're going to be adding up all the sides. And we have 4 sides in our rectangle. If we want to label the other 2 pieces, right, we have an x value here, and then this other side is going to be a y. So we've got x plus y plus y, and that's going to give us our perimeter. Well, we know we're working with 3,000 feet of fencing, so we've got 3,000 equals 2x plus 2y. Okay, and I can use this equation to solve for y. That way I can go ahead and plug in for the y that we see in that area formula. So let's go ahead and solve this for y, which means we want this to read y equals, so let's go ahead and subtract the 2x from both sides. That's going to give us 3,000 minus 2x equals 2y. And now we can go ahead and divide both sides by 2, which means we're going to divide each term here by 2. So our y value is going to equal 1,500 minus x. Okay, we can go ahead and substitute this in for the y value that we see in our area formula. So we're going to get the area equals x times 1,500 minus x. Okay, and that's one way that we can write our answer for part A. Right, we have an area formula all in terms of x. We could also go ahead and distribute this x through. So a second option is going to be 1,500x minus x squared. Or some people might like to have their x squared term first, and that's fine. We can always reorder this. Just make sure that you keep the signs the same on each of your terms. So I've got negative x squared plus 1500x. Right, so any of these three options would be okay in this scenario. I'm actually going to go ahead and use this last one just because it's in descending order and it's going to be a little bit easier for us to pull off A and B values as we go on to other pieces of the problem. So let's go ahead and look at part B. We want to calculate the value where x is the largest. So keep in mind, if we're working with our answer for part A here, right, what we ended up with is a quadratic. We can go ahead and calculate the a and b values off of this function. Our a value here is a -1. Right, so we know this is a parabola that's going to be opening downward. If we give ourselves a little sketch here, if it opens downward, that means it's going to have some type of max value at the vertex. Right, and part B is asking us to figure out what that x value is, right? And if I just pretend that this is on some type of grid here, right, we're going to be looking for this x value from that vertex. So for part B, we're going to need our axis of symmetry equation, which is that x equals -b over 2a. And we know our a value is -1. Our b value here was 1500. So we can go ahead and plug those in. We've got a -1500 over 2 times -1. So we've got a -1500 over a -2. And this is going to give us an x value here of 750. So let's go ahead and actually put this on our diagram. And keep in mind you want to include some units here, right? We're measuring in feet, so our length is going to be 750 feet. Now let's go ahead and work with some additional information here. I know the problem didn't ask us for this information, but let's go ahead and talk about it anyway. Right, pretend the question was going to ask us about the dimensions of this rectangle. Right, we know the length is 750 feet. We would still need to be able to calculate the width if we were being asked for the dimensions. And we can actually go ahead and use some information that we've already come up with while we were working in previous parts of the problem. Over here, when we were working with our perimeter, you'll notice that we ended up with an equation that says y equals 1500 minus x. We can actually use that to calculate the width of this rectangle. Right? We know our x value was 750, so we can actually come here and plug it in. Right? And we can get a y value here of 750. This one is also in feet. So we now have our dimensions to our rectangle. And for part C, they're asking us to calculate the maximum area. Well, we began working with that part of the problem when we first started. Right? Remember that area was the same thing as our length times width, which for us was our x value times y. And we know both of those dimensions, so we can go ahead and plug these in. We've got 750 times 750. Which is going to give us 562,500. And we want to make sure we go ahead and put units on this. Since we're working with area, this is going to be square feet.